Welcome back, children. Now let us look at the worksheet number 4 of wave motion chapter. So let us move with the first question. Here we go. First one. The velocity of sound in air is 344 meter per second. So velocity V is given as 344 meter per second. What is the wavelength of a sound wave of frequency? What else is given? The value of frequency is given as 32 hertz. Two things you have given. Wave velocity was given as well as frequency is given, and you are asked to find the value of wavelength. You are asked to find out what is the wavelength. So these are the three relations. But what is the relation between wave velocity, frequency and wavelength, children? We know that V is equals to lambda by T. What is the formula? V is equals to lambda by T, or V is equals to 1 by T can be replaced with F. So V is equals to lambda F. So the relation between wave velocity, frequency and wavelength is given as V is equals to lambda F. Substituting all the values, let us try to find out the value of lambda. If V is equals to lambda F, then what must be the value of lambda, children? Lambda must be equals to, keeping this here, bringing the F other side, then bringing this F other side, it will come to denominator, then V by F is the value of lambda. So this is what you need to find out. You are asked to find out the value of lambda. So what is the formula for lambda? Lambda is equals to V by F. Lambda is equals to V by F. So what is the value of V? Value of V is 344. And what was the value of frequency given? 32. That's it. So let us simplify this carefully. Let us go with 4. 8 4s 32. Here 8 4s 32 and 6 4s 24. So how much are you getting? It's 86 upon 8. Further simplification gives it as how much? 86 by 8 will be approximately equals to 8 ones 8, 0.60, 8 6 ja, 7 ja 56, isn't it? 40, 8 5s are 40. Hence, wavelength measured in SI system, it is measured in meters, meter per second, and hertz given in SI system. So, length is measured in meters in SI system. Hence, the correct option is 86 upon 8. If you divide it carefully, you will be getting it as 10.75 meters, and hence, second option holds good. What is the correct option, children? 10.75. Just to go through the given data. Identify the formula. What is the formula? Either V equals to lambda by T or V equals to lambda F. This is the proper relation. The value of V and F were given and you are asked to find out lambda. Lambda equals to V by F. Substitute the value of V as 344 and F as 32. Simplify this to get the answer as 10.75 meters. Moving ahead with the second question. A wave travels at a speed 330 meter per second. So what is given? Speed means wave velocity or wave speed is given as 330 meter per second. If the wavelength is 2.2 centimeter, wavelength indicated with the letter lambda, and this is given as 2.2 centimeter. Observe this carefully, children. This is given in SI system, whereas this is given in CGS system. But if you identify the options, they were given in hertz, means again in SI system. So this you have to convert. You should not take this in centimeter. You should convert it in SI system, that is in meters. How to convert centimeter in meters? We know that 1 meter is equals to 100 centimeters. So 1 centimeter will be equals to 1 by 100 meters. 1 centimeter is 1 by 100 meters. Then 2.2 centimeters is 2.2 by 100 meters. 1 centimeter is 1 by 100 meters. 2.2 centimeters is 2.2 by 100 meters. So this is now in SI, this is also in SI system. You are asked to find out the frequency. So children, what is the relation between wave velocity, frequency and wavelength? We already discussed it in the previous numerical, that is V is equals to lambda F. So what is the formula? V is equals to lambda F, or V is given, lambda is given. So what you want to find out? Frequency. So let us carry the lambda other side. Therefore, the value of V by lambda is give you frequency. To calculate the value of frequency, you have to divide the wave velocity with wave length. So let us substitute and divide. So to get the value of frequency, substitute V. What is that? 330 upon lambda. How much is the value of lambda? 2.2 by 100. 330 wave velocity upon lambda 2.2 by 100. So simplifying this, how much are you getting? Bringing this to here. 330 into 100 upon 2.2. I want to remove this decimal, children. In order to remove this decimal, I have to multiply numerator and denominator with 10. Then 330 into 100 into 10, you'll be getting it as 330 into 1000 whole upon 2.2 into 10, you will be getting it as 22. So I try to remove the decimal. So now dividing 11 2s 22, 11 3s 33, and here is your 0. Further simplification gives this goes 15 times. Therefore, the final value of F is found to be 15 into 1000 is 15,000. And what are the units of frequency in SI system? Hertz. So, how much you got it as? 15,000 Hertz. So, option 1 must be true. So, what is the correct option? The frequency of the wave is found to be 15,000 Hertz. So, goes with option 1. Moving ahead with the next question, children. Question number 3. So, let us look at the question. Calculate the wavelength of radio waves. Again, you are asked to find out wavelength, lambda. Wavelength means lambda. Of radio waves of frequency 1, it's not 109, children. Small correction is there. So, just it must be 10 power 9, children. How much is that? It must be 10 power 9 Hertz. The speed of radio waves is again given as 3 into 108. It's not 108. It must be how much? 10 power 8. So, make these corrections. Yeah. So, now try to understand the question. Calculate the wavelength of radio waves. So, what you are asked to find out? Wavelength, lambda, you are asked to find out. Frequency of frequency F is given as 10 power 9 Hertz. The speed of the radio wave, speed of the wave is V is found to be 3 into 10 power 8 meter per second. So, frequency as well as wave velocity both were given in SI system, but answer in centimeters it is given in CGS system. So, we have to convert final answer in CGS system. So, meanwhile, let us substitute the values. Formula, what is the formula? V, F and lambda. V is equals to, the relation between V, F and lambda is V is equals to lambda F. But you are asked to find out lambda. So, in order to find out this lambda, keeping it aside and bringing all other terms to the other side, bringing this F to the here, it will become V by F is equals to lambda. So, in order to find out the value of lambda, you have to replace with V upon F. Substituting the given values, children. So, lambda, I'll go here. So, lambda equals to V by F. What was V? V was given as 3 into 10 power 8. F was given as 10 power 9. Is it? Well, and this will be equals to 3 into 10 power 8 into 10 power 9, if it is brought up, it will become 10 power minus 9, and hence the value of lambda is found to be 3 into 10 power minus 1 meters. 3 into 10 power minus 1 meters. But answer you want it in centimeters. You want it in centimeters. But children, what is the relation between meter and centimeter? We know that 1 meter is equals to 100 centimeters. So 1 meter is 100 centimeters. So lambda must be equals to 3 into 10 power minus 1. Instead of meter, I have to replace it with 100 centimeters. Now you got the answer in centimeters. Or lambda equals to 3 into 10 power minus 1 into 10 power 2 centimeters. Minus 1 plus 2 is 1. So lambda equals to 3 into 10 power 1 centimeter. 10 power 1 is 10. So this is equals to 30 centimeters. So how much is the value of lambda? 30 centimeters. Okay. Well, if you can't understand this, you simply cancel out 10 power 8. If this goes up, you'll be left over with the 10, 3 by 10. 3 by 10 meters. If you want to convert in centimeters, multiply it with 100. Then 3 by 10 into 100, you'll be getting it as 30 centimeters. It's all up to you, whatever method you follow. Okay, simplification is up to you. Moving ahead with the next question, fourth one. Calculate the wavelength of the wave generated by a tuning fork. So tuning fork is there. So when the tuning fork is being vibrated, waves are coming out, sound waves. And the frequency itself is given as 256 Hz. So what is that? Frequency of the wave F is given as 256 Hz. This is the given data. Velocity of sound in air. Velocity of sound in air at ordinary conditions is given as 340 meter per second. Both given in SI system. Answers also you got it in given in SI system. But you're asked to find out wavelength. Wavelength means lambda. So this you have to find out. So let us recall back the formula, children. The relation between V, F and lambda is V is equals to lambda F. V is equals to, what is that, children? V is equals to lambda F. In order to find out the value of lambda, lambda is equals to F. You bring it here. It will become V by F. So lambda is equals to V by F. Is that true? So as you want to find out lambda, you have to substitute the values. So find out lambda. Lambda must be equals to V by F. So what is the value of V? V, you take it as 340 meter per second and F as 256 Hz. So simplifying this carefully. So there is nothing much about the simplification. It's better to divide this. Okay. 340 when divided with 256 goes one time. And here you have 256. This is 4. And 13 minus 5 is 8. That's it. So 256 once you are getting it as something reminder, you have 84. Further simplification, you have to keep 0. So if you keep 0, you have to keep somewhere decimal here. Okay. So 256 when multiplied by 3 times, how much you are getting? 6 3 is 18, 768. So 3 times you are getting it as 768. Remainder is some here 2 and 772. Okay. So further simplification, you can have a 0 here. Again 256 multiplied by something like 2. You will be getting it as 256 times of 2 is 512. And some additional value you will be getting. Up to 2 decimals is enough. So 1.32 approximately, some other value you will be getting. So 1.32 approximately equals to 1.33 meters, children. So how much is the value of lambda? The value of lambda is found to be 340 upon 256 is approximately 1.32 centimeters. Hence, the nearby value for 1.32 centimeter, sorry, that's not centimeters, it's meters. The value nearby 1.32 meters is 1.33. Hence, option 1 is taken as true. Moving with the next question, fifth one. A tuning fork produces 256 waves in 2 seconds. How many waves are produced? 256 waves, a number of waves, a number of vibrations. Calculate the frequency of the tuning fork. Children, as I told you that frequency is defined as the number of vibrations per second. Number of vibrations per second or number of cycles per second, or number of cycles means number of waves. So 1 cycle, 2 cycle, 3 cycle, 4 cycle, like that. So number of cycle means how many waves are produced. Like this, okay? So number of waves or number of cycles or number of vibrations per second. So as they gave number of waves, I'll write instead of cycles, number of waves per second. Okay? So what they were giving is in 2 seconds 256 waves are produced, but I want it in 1 second. So I have to divide the given waves with 2. So this is 256 upon 2. Then you will be getting for each second. So simplifying this, how much is that? 2 ones, 2 twos, 4 and 8. 128 Hertz. Okay, frequency is nothing but number of waves per second. This can also be solved in another way, children. And how means in 2 seconds it produces 256 waves. In 1 second, how many waves are produced? So let us divide these two equations. So 2 by 1 is equals to 256 by x. Cross multiply, x comes here, 1 comes here. X is equals to 256 by 2. Again, you will be getting the same answer, that is 128. So 128 waves are produced in 1 second. So 128 waves per second itself is called as frequency. So what is the frequency? 128 Hertz. Okay. So moving to the next question, children, sixth question. The frequency of a source of sound is 100 Hertz. What is given? Frequency F was given as 100 Hertz. How many times it vibration in 1 minute? In 1 minute, how many vibrations it takes place? So this is what they were given. So let us rewrite the given data once again, children. So what is given means frequency of a source means it vibrates for 100 times in 1 second. So in every 1 second, it vibrates 100 times. Every 1 second, it vibrates 100 times. But you are asked to find the same in 1 minute. So 1 minute, how many times you have to find out. So let us divide both. Then you have 1 second upon 1 minute will give you 100 upon x. Let us cross multiply these two. Then x is equals to 100 into 1 minute. So x seconds. In x you want it in seconds. X seconds you have to multiply. So, but you are getting the answer in minutes. So, you have to convert in seconds. So, 1 minute can be written as 60 seconds. So, x in seconds, how much are you getting, children? Therefore, the value of x is equals to 6000 seconds. The correct option is option 2. So, what is the correct option? 6000 seconds. If 1 second, in 1 second, 100 times it vibrates means in 1 minute, so 100 times of 60, okay, it will be 6000 times. It will vibrate for 6000 times. You should not say second, children. It should vibrate for 6000 times. Let us move to the next question. 7th one. The time period of an electromagnetic wave is 10 power minus 15 seconds. So given that the time period is 10 power minus 15 seconds. This is the given data. What is the frequency of the wave in hertz? You are asked to find the value of frequency. But children, what is the relation between frequency and time period? F is equals to 1 by t. So 1 by value of t is given as 10 power minus 15. Earlier I told you that if it is minus 15 in the denominator, if it is carried upward, then it will become 10 power plus 15. How much? Or it can also simply written as 10 power 15. Minus carried up become plus, plus carried up becomes minus. So what is the frequency? 10 power 15 hertz. So where is the correct option? First option, that is 10 power 15. Hertz units already they gave it as. Okay, F equals to 1 by T, 1 by 10 power minus 15 is 10 power 15 hertz. So children, moving with the next question, 8th one. A sound wave traveling in air has wavelength 1.6 into 10 power minus 2 meters. So what is given? Wavelength indicated with the lambda equals to 1.6 into 10 power minus 2 meters. This is given. If the velocity of the sound is 320 meters per second, velocity indicated with the letter V equals to 320 meter per second. Calculate the frequency of the sound. You are asked to find out frequency of the sound. So, lambda is given, V is given, you are asked to find out the value of F. So, before starting with, let us recall back the relation between V, F and lambda. So, what is the relation, children? The relation between V, F and lambda is equals to V is equals to lambda F. V is equals to lambda F. But as you want to find out the value of F, keeping the F here, bringing the lambda other side, V by lambda will give you the value of F. V by lambda give you the value of F. So, let us try to substitute and solve the value. So, what is value of F? F is equals to V by lambda. How much is the value of V given? 320 meter per second. And value of lambda was given as 1.6 into 10 power minus 2 meters. So 10 power minus 2, if it is carried upwards, it will become 320 into 10 power plus 2. Minus 2 will brought it up means it will become plus 2 upon 1.6. Upon 1.6. So let us remove the decimal by multiplying and dividing with the 10. So then how much will be the value of F? F is equals to, so 320 as it is, 10 square into 10, how much you'll be getting? 10 square into 10, 10 means 10 power 1. So this will be 10 power 3. 1.6 into 10, you'll be getting it as 16. That's it. 320. 10 square into 10 is 10 cube upon 1.6. 1.6 into 10, you got it as 16. So, dividing this, 16 2's 32 and here it is 0. Hence, the value of F is found to be 20 into 10 cube is nothing but 10 after 1 after 3 zeros. And hence, this value is equals to 20,000 hertz. How much is that? 20,000 hertz, and hence the correct option is option 2. Option is 20,000 hertz.